Thanks everyone for joining in, and thank you for having me. I look forward to the summit every year, and this year is no exception. I'm very excited to talk to you about analytics and AI and how you're reimagining the boundaries of what it can achieve. So many new AI capabilities have been talked about at the summit already, and today I wanted to draw your attention to something that should be at the crux of all this innovation: responsible AI practices. Looking at how the world has changed around us over the last few months, and more so over the last few weeks, has greatly amplified the need for us to ensure fair practices and ethical behavior across all sections of society. To get a sense of the intensity of this topic, Capgemini published late last year that nearly 9 out of 10 organizations have encountered ethical issues resulting from the use of AI. These executives cited reasons including a lack of resources dedicated to ethical AI systems, the failure to consider ethics when constructing AI systems, and the pace at which AI is touching every part of our lives. The statistic is alarming. We as a community have a duty to address these issues head-on and empower organizations to use AI with a sense of responsibility. At Microsoft, we've also heard these concerns firsthand from our customers. As a result, we've invested in the advancement of AI driven by responsible principles that put people first. Our approach to responsible AI is anchored around the following focus areas: keeping ethical principles at the core of everything we build, enabling governance and operational transparency to drive right practices, leading efforts for public policy at the highest levels, and finally, empowering teams with cutting-edge tools to encourage responsible AI practices. Now, since the Spark and AI community comprises majorly of developers and data scientists, we'll focus on the tools. In collaboration with Microsoft Research, we are bringing the latest of research in responsible AI to Azure. Over the next few minutes, I will talk about how the new responsible machine learning capabilities in Azure and our open source toolkits empower data scientists and developers to understand machine learning models, protect people and their data, and control the end-to-end machine learning process. Let's look at each of these 3 pillars in detail. First, let's look at the understand pillar. It comprises driving an understanding of the model's fairness index and its interpretability. But what does that mean? One challenge with building AI systems today is the inability to assess and mitigate unfairness in the models. To address this challenge, we've recently open-sourced a toolkit called FairLearn. There are 2 components to FairLearn. First, focused on fairness assessment, is a dashboard with both high-level and detailed views for assessing which groups are negatively impacted. Second, focused on mitigation, is a set of algorithms for mitigating the observed fairness issues. These strategies are based on a variety of supported fairness definitions, such as demographic parity or equalized odds for classification tasks. The supported unfairness mitigation techniques can easily be incorporated into existing machine learning pipelines and assess model fairness during both model training and deployment. Together, these 2 components enable data scientists and business leaders to navigate any trade-offs between fairness and performance and to select the mitigation strategy that best fits their needs. Using FairLearn, developers and data scientists can leverage specialized algorithms to ensure fairer outcomes for everyone. Another important aspect of understanding a model is the ability to interpret or explain its results. This is where Interpret ML comes in. As the name suggests, it helps interpret models and their results. Interpret ML is another toolkit we've open sourced and can be used for both glass box and black box models. Glass box models are designed to be interpretable. They provide lossless explainability as they use interpretable algorithms like decision trees or explainable boosted machines. Interpret ML can help visualize the various features affecting the outcome of a model in an interactive dashboard and even allow for what-if analysis. On the other hand, black box models are based on more complex techniques like neural networks and can be a little tricky to interpret. You can still achieve approximate explainability with black box models using explainers like LIME or SHAP. Interpret ML uses these explainers to surface a dashboard with feature importance. Interpretability is needed to ensure that there is optimal transparency within models to assess and reason through the predictions it generates or the recommendations it creates. With Fair Learn and Interpret ML, you can gain a very good understanding of your models. Let's now look at the Protect pillar. Protect refers to protecting data against any potential misuse used to train the models. To understand this better, let's envision a scenario where a data scientist wants to use some sensitive data to create a model. In a non-protected scenario, this would result in submitting a query to the private sensitive data set, and provided the right credentials, they'd receive sensitive data as a response to their query. Well, this is problematic. Now the data scientist can look at the sensitive data and potentially deduce PII information about an individual. This is clearly not at all compliant or ethical. Now let's introduce a differential privacy toolkit within the OpenDP initiative that has been developed by Microsoft in collaboration with the researchers at Harvard's Institute for Quantitative Social Science. This toolkit ensures differential privacy by first managing exposure risk, by tracking the information budget used by individual queries and limiting further queries as appropriate. In our example, the query is first validated against the information privacy budget and processes only if it isn't overrun. Second, it injects statistical noise and data without significant accuracy loss to help prevent disclosure of private information. Again, in our example, because the query response may be sensitive, before it reaches the user, it is injected with noise to make it differentially private. In addition to differential privacy, you can also protect your data on Azure using hardware-backed confidential machine learning capabilities and homomorphic encryption and ensure your data isn't compromised at any stage of the machine learning lifecycle. The third pillar for responsible ML is control. It refers to tracing the lineage of models and supporting a standardized format of documenting it for cataloging and reusability needs. On the control side, there are some features and capabilities that allow you to manage your audit trail and data sheets for the models. Within Azure, all the actions undertaken throughout the lifecycle of a machine learning model can be tracked for auditing purposes. This audit trail enables us to trace the lineage of the training data, the operations performed on it, its drift, and most importantly, the model versions and the various deployment endpoints. Now, this is important. For compliance reasons, organizations can leverage this audit trail to trace how and why a model's predictions showed a certain behavior. Additionally, once you have a model, it is important to capture its properties and purpose alongside any other metadata that could be helpful from a reusability standpoint. In Azure, we enable this with custom tags you can define for the models and capture all its information so that it travels with the model. Audit trails and data sheets enable accountability for models and are an integral component of responsible ML. I've been talking about quite a few capabilities, so let's bring them to life with a demo. Let me invite Sarah Bird to demo these toolkits and show how you can use them. Sarah?
Thanks, Rohan. Hello, everyone. Today I'm going to be walking through a demo of some of our responsible AI tools on Azure. As we progress through the ML lifecycle, I'm going to be demonstrating 3 key capabilities: protecting sensitive information with differential privacy, assessing and improving model fairness with Fair Learn, and analyzing and explaining model behavior with Interpret ML. In this demo, I'm going to be building a model for loan applications to decide which to accept and which to reject. Let's dive in. Here I'm using Azure Databricks, but you could also use a Jupyter notebook or your favorite Python environment. Like any good model building scenario, the first thing I want to do is look at my data. Here I'm looking at aggregate information as well as individual features to help give me a feel for the data set and uncover any potential issues up front. It looks like this data set contains a lot of great data to help me build my model. It also contains highly sensitive information that must be kept private. Obviously, I can limit direct access to the data with the data store. However, what many people don't realize is that aggregate values can still be used to reveal private information about individuals. Let's go to an example to see what I mean. So here I'm going to demonstrate how we can use aggregate information to reconstruct the data set. So in this case, I'm going to assume that I know aggregates about individuals' income, as well as a little bit of additional information about two individuals in the data set. And with that, I can take an off-the-shelf SAT solver and use that to reconstruct a data set that's consistent with the information that we know. So if we run our SAT solver here, it's working to reconstruct that data set, and we see that it can actually find a result. And now we're going to compare that to the real data set and see how well our attacker did. So in this case, it looks like the attacker did pretty well. We're able to correctly reconstruct the incomes of individuals within $5,000 for more than 20% of the data set, which could be a significant privacy violation. So what do we do about attacks like these? How do we use data but still protect privacy? And this is where differential privacy can help. So differential privacy hides the contribution of individuals in the output computation by adding a small amount of statistical noise to the query. The noise is significant enough to protect the privacy of individuals, but often small enough to still allow us to use the data. Differential privacy also calculates the amount of information that is revealed in the query and subtracts that from an overall privacy loss budget. Let's look at how this works. So here I'm going to use our open source differential privacy platform, and now I'm going to add that statistical noise to the income information. And then I can retry my attack with my SAT solver. And what you'll see here is that we get a very different result. We aren't able to reconstruct a data set that's consistent with the differentially private incomes. And so we don't have any guesses at any private information. However, it's not enough to just protect privacy. We still want to be able to use the data. So let's look at how we're doing here. In this case, you can see that we're looking pretty good. We're pretty close to the original information. You can definitely see some noise added, particularly because this is a small data set. However, now I can take this and go and use it in my problem, knowing that I don't have to be concerned about privacy attacks. So one of the ways that we can use differential privacy in machine learning is to generate synthetic data sets. So here I'm going to use my open source toolkit, and I'm going to create a data set that matches the patterns and trends of my original data set, but doesn't reveal any private information. And that way I can take that and give it to my data scientist without having to worry about privacy. So I'm going to generate my data set here. And now that I have my private data set, I can go and build my model. So here I'm going to build a scikit-learn model for my problem. And now that I've built the model, I want to actually analyze the performance and see, is it good enough for my problem? So of course, I can look at traditional metrics like accuracy. However, since this is a problem where a wrong decision could have a significant impact on an individual's life, it's important that I go a step farther and I also consider the fairness of my model. So in this case, I'm going to use fair learn so that I can understand how well my model works for different groups of people and make sure that it's not using sensitive attributes to make decisions. So in this case, I'm going to use fair learn, and fair learn has an interactive dashboard to help me better understand the fairness assessment. So I'm going to click Get Started here, and my data set has two values, sex and race. So let's click into sex and understand how well my model's doing. But I also need to provide a performance metric, which metric's important for my problem. So in this case, it's accuracy. So I'm going to click through. And the first thing I have is a graph here that helps me understand the difference in model performance across these two groups. So I can see that my model's more accurate for women than men, and it's about 85% accurate overall. However, I'm really interested in the outcome of this model. What's the difference in who I'm offering loans to? So in this case, I can see that I'm offering loans to 19% of people overall. However, I have a significant difference in the number of loans I'm offering to women and men. I'm offering loans to about 7% of women that apply and about 25% of men that apply. Now, I don't necessarily know if this is a problem. It could be that these two groups have very different distributions. However, I do know that it's a sign that I want to dive in and investigate further. So for that, I can use Interpret ML and its black box explanations. So I'm going to generate explanations for my model here, and then I'm going to use its interactive dashboard to explore those and understand how it's making its decisions. So in this case, I'm going to set up 2 different cohorts. So let's set up one for women so we can understand what's going on there. So I'm going to add a filter for sex, and women are 0 in this data set, so we can add this filter, and I'm going to save. Then I'm going to add a second cohort here for men, and I'm going to select this. And in this case, I'm setting up for men and women since I want to look at this fairness problem, but you could use lots of different cohorts like train and test to compare as well. So in this case, what we can see is the model performance, just like we saw in Fair Learn, but in a lot more detail. However, what I want to do here is jump over to the explanations to understand the feature importance and how the model's making decisions. And what I can see right away is that the model is using sex directly as a feature to make predictions for women, but not necessarily for men. And if I click on this, I can actually dive in and see that for women, for every single woman in the data set, the value of sex being 0 is directly contributing to the prediction that they are rejected, which is pretty concerning. And so what I want to do at this point is move on and explore mitigation techniques. So for that, I can go back to Fair Learn and use some of the built-in mitigation algorithms that allow me to reduce disparity either during training or after. So in this case, I'm going to use the grid search approach where I'm going to retrain many different models by reweighting the data to try to reduce the disparity. So I've run my model training here, and now I can go back to the Fair Learn dashboard to look at the best models. So in this case now, I have a range of models that are along the curve of difference in predictions and accuracy. So here's my original model up here, and now I'm actually going to click through and look at this model, which is a little less accurate, about 82% accurate. But if I jump down to the disparity in predictions, I can see that I have a much different outcome. Now I'm offering loans to 15% of men and 14% of women that apply. So this might be a much more promising model for my problem. And so what I'm going to do now is actually save all of my work so that I can share it with collaborators or show it to other stakeholders as we make a decision about whether or not we want to move forward with this model. So I'm going to register all of my models here. I can upload my dashboards and my explanations, everything to Azure Machine Learning. Then if I move over to my Azure Machine Learning Studio here, then I can click on a particular run. And so here's my different runs, and I can click into one. And now I can actually have my dashboard stored directly with my model, as well as the fairness. And so now I can show this to other stakeholders or compare to previous models as I decide whether or not I want to take this into production. Back to you, Rohan.
Thanks, Sarah. It was so nice to see all of these machine learning tools come to life with the loan scenario. Just to add more color, this demo is very similar to what Eva is doing with these toolkits. They're using Fair Learn extensively to mitigate unfairness in models. They've been able to reduce their disparity by more than 90%, which is amazing. And many more customers are using these toolkits to build responsible machine learning practices. I want to take this opportunity to invite the community to get involved. Contribute to the open source projects powering responsible machine learning capabilities. Create scalable impact with the objective of having ethical AI practices and solutions. All these tools are hosted on GitHub and already have hundreds of downloads within the last few weeks. If you want to try them in action, please use the Azure links to try them within Azure Machine Learning or Azure Databricks. With that, I want to thank... Oh wait, did I forget something? Well, I must let you in on a little secret. This one about my presentation environment. I'm sure most of you think I'm in front of a green screen here, and there are some graphics people doing their magic in the background. We thought of experimenting with AI a little bit and putting it into the use just for the summit. First, let me show you where I am. This is not a formal studio. It is a normal living space where I just came in to record this talk. Now let me show you how it was converted to a presentation stage for me. We use Kinect and the Azure Kinect Dev Kit to bring AI and AR together to simulate the stage. Here's an architecture of the solution that produced the video for this talk. Amazing, isn't it? We use normal camera images and depth sensing Kinect camera images to replace my actual background with the stage and design of our choice. I thought about a beach in Hawaii, but opted for a bit more presentation-friendly option. This is just an example of how together we can stretch the boundaries of AI. The solution has been published in a GitHub repo, linked here for you to use for your next meeting or video call. Again, thank you for the opportunity to share. I hope you have a great summit. Please stay safe.